Hello. Today we are going to be solving Leetcode 211, design and add search word data structure. I've already solved a similar question, that is Leetcode 208. I have explained what a trie data structure is, and basically that's the same approach we are going to use to solve this. The only difference is we're going to do a little bit of DFS updates on search because there is a wildcard introduced here in the question. But if you are not familiar with trie data structure, I would recommend you watch that video. I did a brief summary of what trie data structure is and how you add and search. That would be very helpful. Otherwise, if you're already familiar with trie data structure, you're good to go because this is just going to be a breeze for you. So first, let's create our trie node class. So trie node. We're going to initialize it. So we are going to set its children to a dictionary, and then we're going to set its flag, which is whether it's a word or not, to false. All right. So we initialize the dictionary class with a self with a root node that is going to be empty. So that is a new trie node. Right, and then we are going to do the addition, which is going to be same as what was done in 208, and that is we set our node to the root node. Right, and for each character in word, if the character is not in node.children, we need to set up a new child. Key and a new node. Right, however, if it's in there, we just proceed, right? So node dot children dot the new character, and once we get to the end, we verify if it's a word. We don't verify, we set it to true. Okay, so now this is how words are added. Right, now the next step is checking if a word exists. So with that, we are going to use a DFS and then an I index. Right, index, right? So if the index is equal to the length of the word we are searching for, it means we have gotten to the end of our search. All we need to do is return that node's flag, and that will tell us if it's a word or not. However, so the character is, if that's not the case, right? If that is not the case, and if the character is equal to the wildcard, what we are going to do is, because the wildcard can take anything else, we look at all the possible outcomes, right? All the possible outcomes for that scenario. So for character in node.children dot values, possible values, right? We do a DFS. For the next one. If that is true, we return true. Else we return false. That's not the case then. However, if it's not a wildcard and if the character we are just on is not in node.children, we return false too. That's not what we are looking for. Otherwise, we just return DFS, the node the new node. For that character, and then we go looking for the next index character. I think I missed that here too. Okay, so this is it. It's a simple DFS with slight modifications here to accommodate for the wildcard. Other than that, it is a DFS. So we return our DFS with our root node, and we start from 0. All right, so this is how we solve and create for it. Let's see if I missed something. DFS. So I missed the DFS, hopefully. So node.children, I misspelled children. Hopefully that's the only typo in there. Whoa, so that looks like that is it, and that is good. So thanks for watching. See you in the next one.